Okay, this will be the prep video for section 5.2, integration by substitution, which I really think of as reverse chain rule. So first, let's go over the integration rules that we learned from last time. So we have three basic integration rules that are power functions, exponential functions, and log functions. So we know when we have a power function to do the antiderivative, remember the integral sign means do the antiderivative, it's an action. We raise the power by 1 and divide by. Add plus c, because we don't know that yet. We don't have anything to pin that information down with yet. Integral of e to the x is e to the x, love that, plus c. Integral of 1 over x, this is ln, natural log of x. We need to use absolute value in order to make sure that I'm having trouble, make sure that the input to the log is positive, and then add plus c. Importantly, this is not a power rule. If we tried, and rewrote it this way, if we tried then to raise the power by 1 and divide by, we get a mess. So this is not a power rule. And if you try, you just know that it won't work. It's okay to try. You'll just find out quickly it won't work. We still know that multiplication by a constant and addition and subtraction carry through like they do for derivatives. Okay, so now let's look, and as I pointed out last time, there is no reverse product rule and no reverse quotient rule. However, there is a reverse chain rule. So let's review chain rule. Chain rule we used when we had some function that was inside another function. So remember, these brackets do not mean multiply, they mean a function of a function. So what would be a good example? How about x squared minus 7 to the 5th? Let me change that to the 6th. Okay, so I have an inside function and an outside function. And so when we do the derivative, when we differentiate, let's remember what we did. We dealt with the outside function first. So we did the derivative of the outside function, leave the inside alone, just leave it the way it was. So let's do that first. So derivative of anything to the 6th will be that something to the 5th times 6. So what goes in here? The inside function, because we haven't changed that yet. But now we have not taken the derivative with respect to x. We took the derivative, we just did the outside function. So we still have this mess on the inside that's not a plain x. So that's where we then took this whole thing, which is this, and multiplied by the derivative of the inside. What's the derivative of this inside? 2x. So that suggests to us that if we look at this pattern, remember this is differentiation going this way. If I wanted to anti-differentiate and go the other way, let's look at the pieces that are required. If I see that I have a nested function, an inside function and an outside function, I'm not so worried about the constant in the front. Remember, we can multiply by constants. That's not a big deal. But what is important is that this piece, the derivative of the inside, has to be there. So what's the derivative of this? 2x. Is it there? Yes, it is. So that means that this, all the pieces I have, the derivative of the outside and the derivative of the inside, I have them both, so I can go backwards to this original function. So I can anti-differentiate to this function. So the important part is, in order to anti-differentiate, you have to have the derivative of the inside sitting right there. Okay, so let's do some examples. All right, let's look at this one. X squared minus 7 to the 5th 2x dx. And I'm going to give you a format that I would like for you to use for your assignment, just to make sure that you know and I know that you know what you're doing. So I look at this, and I see two functions multiplied. I know I don't have a reverse product rule, so I can't even start thinking that way. So anytime I see this, I say, well, I've got this function raised to a power. I have a nested function, a composite function. I have this situation. So come over here. What do I need? I have a derivative of the outside times the derivative of the inside. This is the part you need to make sure you have first. So here's the derivative of the inside. I would like for you to underline it and then draw an arrow and write what its derivative is. The derivative of the inside is 2x. Do you have it? Yes. So that means that you have essentially, tell you what, let's put a 6 here to start with. That means that you have everything you need, you have this part, to start looking at the outside function. So looking back here, with the derivative of the inside sitting there, when you go back here, it gets sucked in. That's one way to think of it. This derivative here gets sucked back inside. And so the only thing you need to worry about, if it's there, the only thing you need to worry about is the outside function. So let's look. Is the derivative of the inside here? Yes. So that means I don't need to worry about that piece. It's going to get sucked in. Now I just need to worry about the outside function. 6 something to the 5th. So power rule says raise that to the 6th. The 5th gets raised, and then divide by 6. 6 over 6 is 1. Or you might recognize that 6 something to the 5th is automatically just that something to the 6th. Done. That's it. Plus c, of course. But the derivative of the inside is sitting here. It gets sucked in. That means really all I'm worried about is this outside function, 6 something to the 5th. This is where the substitution part comes in. If it helps you, think of this as 6u to the 5th. All right, and this will go to u to the 6th. But what was u? U was that inside function. So if it helps you to kind of put away the outside function, the inside function, that's fine. To be more formal about this, let me just present a little bit more. So if I'm saying that u is equal to x squared minus 7, then I can find a differential, let's remember those, which is just simply the derivative, right, du dx, but then written this way, du, solve for du, so 2x dx. So coming back up here, if I were to take this information and replace what I have here, I'd have the integral sign, 6. This whole inside is u to the 5th, and then this whole piece is my du. Oh, well that's easy. This one is just u to the 6th plus c, but now go back in and stick in your original function. You can do it this way. For some of the simpler problems, this is a long way to do it. So I don't recommend doing it. You can do it this way to start with if it helps you to see all the pieces, but I recommend if you can start moving towards doing it this way, where you just say you recognize there's an inside function, find the derivative. Is it there? Check. If it's there, concentrate on the rest. Know what to do with the outside function, add your plus c. So let's look at another one. We're going to look at this one again, but we're going to take out a constant and talk about what to do with that. So what if instead I had this, x squared minus 7 to the 5th, 2x dx. Okay, again, I see two functions multiplied together. I do not have reverse product rule, so I need to think about this is the inside function and that is the outside function. And with the line and the arrow, what is the derivative? 2x. Is it there? Yes, it is. So now I can just handle the outside function. So the outside function, I have something to the 5th. So the outside function will be that something to the 6th divided by itself plus c. And then you can go ahead and put in the inside. So remember, this derivative of the outside, once you've established that it's the derivative of the inside, once you've established that this is the derivative of the inside, you can ignore it. It gets sucked back in to the chain rule. And so once you verify that it's there in its entirety, then you concentrate on your exterior function. Okay, let's do another one. Integral of e to the negative 4x times negative 4 dx. I would not ordinarily write it this way. We'll look at it written kind of a more normal way in just a minute. Okay, so is this a basic function? Is this just a plain x? No, it is not. This is the inside for the e function. So its derivative, the derivative of negative 4x is negative 4. Is it there? Yes, it is. That means I ignore this piece and concentrate on the outside function. The derivative of an exponent, the antiderivative of an exponential is itself plus c. That's it. Okay? So this negative 4 sitting on the outside is the full derivative of the inside function. So once I've established that, then I can ignore all that, concentrate on the outside function. Normally, you would probably write this like this, minus e to the minus 4x, minus 4e. That would probably be maybe like this, a more logical way to write it with the negative 4 on the front. That's normally how we write things. So just remember that when you're looking for the derivative of the inside function, it can be in multiple places. So it doesn't just have to be right there. Okay. Let's do one more. Integral of 2x over x squared minus 1 dx. So far we've done a power rule and an exponential rule. So you might think that now we're looking at a log function because we haven't done one yet. You're right. So how do I recognize this as a log function? Well, remember when we were doing derivatives, at one point we talked about if you had log of, say, x squared plus, let's do it this way, x squared minus 1, and you wanted to take the derivative, we know that it's 1 over, because logs give you a 1 over, times the derivative of the inside. That's a chain rule. But remember, I also said you could, and then when you rewrite it, you're going to kind of write it like this. And I said one of the things we want to start recognizing is the fact that the derivative of the bottom is in the top. So if the derivative of the bottom is in the top, that should suggest to you a lin. That is the pattern of lins. So let's come back. Anytime I see a denominator, one of the first things I'm going to ask is the entire derivative of this in the top? Yes. So this is like your inside function. Its derivative is 2x. Is the whole thing in the top? Yes. So that means I can just concentrate on this being a ln. So ln of absolute value of that denominator. These are the ones that are a little bit harder to see, and I'm going to show you one that's a power rule that looks similar but isn't. In fact, let's just do that now. So if I had 2x over x squared minus 1 cubed dx, now is the derivative of the entire denominator in the numerator? Well, the derivative of the entire denominator is chain rule, is all of that. Is all of that up there? All of it? No. So this is not going to be a log. The derivative of the bottom is not in the top. So instead, as we often do, we're going to rewrite in power form. Now, let's look again. We clearly don't have reverse product rules, so we're not thinking about that. Here I have an inside function and an outside function. What is the derivative of the inside function? 2x. Is it there? Yes, it is. So that means I can ignore the 2x, that gets sucked back into the chain rule, into the inside, and concentrate only on the outside. So here we would have that raised by 1 would be negative 2, divided by negative 2, or multiplied by negative 1/2, the reciprocal. Go ahead and stick the inside in, and add plus c. So very different answers. So this one, the derivative of the entire denominator is in the numerator. Here, the derivative of the entire denominator, no, not the whole thing. So that suggests rewrite as a power rule. Okay, so I guess that's it. So for your assignment, I want to see underline the inside and show me the derivative, so that way I can know that you know that it's in, it's in floating around somewhere there in the integral. And then just remember, once you've established that, then you can ignore it. Once you know that the full derivative of the inside is sitting here, the full derivative, then when I go back here, see, it just gets sucked back into the inside. And I only have to deal with the outside function. Okay, so I guess that's it.